Hello everyone and welcome back to Up in the Northwoods. It just got done snowing here. We had a little bit of almost an inch of snow, half inch, something like that this morning. Temperatures are warming up finally. We had that freezing cold like all of the country did. We were 20 below at night a couple nights and only like 0 for a high. So we're getting back to normal temperatures and the ability to get back out and enjoy the weather while you're cutting in the woods and doing firewood and resplitting and all the fun stuff we do. So today we're going to talk about my outdoor wood boiler. If you watched our previous videos, you saw me stoke the stove a few times today, and I said I would do a video on it. We just haven't gotten around to it. It's a little warmer now, so we can be outside, not freezing, talking about the stove and showing what the stove is. So we're going to talk basically about the brand, the quality of the stove, how it's made, the hookup from on the back of the stove all the way into the house. Underground we have tubing, but into our shop, which is the in-floor in there, and we do have in-floor in our house. So we're here by the woodshed and the outdoor wood boiler, which is right by the house. I mean, we're only maybe 10 feet away from the house, which is legal. This manufacturer, Crown Royal Outdoor Wood Stoves, is the manufacturer. They basically say 5 feet to 10 feet. Usually about 10 you want it. Insurance companies, some are more strict than that. Some want it minimum of 25 feet or 50 feet. We've seen that. If you don't know already from our previous videos, I was an outdoor wood stove dealer for 22 years. I did have a couple other brands in the very beginning until I found Crown Royal. Crown Royal has definitely been a lot different stove than our first ones. As you can see here on the side, Crown Royal, they're stainless steel. And these are 409 stainless with titanium enhancement. So what that means basically is it's stainless steel, but they put a titanium enhancement into the steel when they make the steel. And it actually resists corrosion, and it also lets the heat transfer better from the fire through the steel into the water. And of course, that's what we want to do to conserve wood. This particular model is a 7400 MP model. It'll heat about 10,000 square feet. They do have another model called the 7400E, which is the efficient model, which is the gasification. This is not a gasification stove. This one basically is the stainless drum, firebox, shaker grate. We do have a damper that you can open here just to, when you're stoking the stove, it allows more of that smoke to go more straight out the chimney versus in your face. Then you put that back in when you're done stoking. We do have a secondary chamber up here. This might be a little dirty right now because I haven't cleaned it in probably about a month. I try to go once a month and clean it out because it gets a little bit of ash buildup and sometimes a little bit of creosote, but not usually. This stove burns pretty hot, especially with dry wood. My wood is all of 2 years old. Actually, this is closer to 3 years old. So it's all beech, ash. We do have quite a bit of oak in there also, and here some cherry, but not much. We usually pull the cherry out. But it's all hardwood. I burn a little bit of pine and basswood during the day, but during the nights and stuff, I use all hardwood. The secondary chamber, basically what happens is the fire is burning down here. It goes up through a hole, and it comes through a chamber that comes back to this front door, then up, and then back through another chamber, and it goes out the chimney. So what it's allowing it to do is gather more heat from the smoke as it's passing through this stainless steel chamber, which is all stainless. Then the water transfers through the steel into the water, so you're pulling a lot more heat out of the actual smoke instead of the smoke going right out the chimney. Otherwise, you're losing a lot of BTU of your wood going out the stack. The outdoor wood stoves aren't the most efficient. They've gotten a ton better from back in the day of 2000 when I started selling these. It's really crazy. This stove eats a lot less wood than my previous stoves did. But anyway, it depends on what you're heating, how efficient your buildings are insulated, doors, windows. There's a lot of factors Tubing in the ground is one of the biggest. It's huge for that tubing to be in the ground. If you buy cheap tubing, you're going to have cheap tubing. My tubing goes under the right here, basically from the back of the stove, and it goes over towards the building. It's only buried about 2 feet just because I did such a heavy insulated tubing that I don't have to worry about it. And as you can see, that water is pumping right now, and there's no melted snow. The ground is rock hard frozen. So it is definitely a very well insulated pipe. One thing you don't want to chintz on when you're buying an outdoor wood stove, first of all, the stove, but secondly, the tubing. You do not want to chintz on the tubing because you will, if you have a 75, 100-foot run towards a home or a garage, whatever, you can lose 20 to 30 degrees of water heat to get to your house. I've seen it even worse than that. I've gone to places, people say I can't get the heat to the house, and they have basically grass growing in January, and you can follow their trench because there's no snow, melted ground, or thawed ground, I shouldn't say melted ground, thawed ground, and grass is growing. It's got green grass this tall. So that is a big problem for most people. They try to chintz out on the tubing. So, and yes, these have gone up a lot. When I bought my first stove, it was like $8,000 for the stove installed. So they've gone up quite a bit. Now this stove, I think, I'm not a dealer currently. I haven't been a dealer in about 2 or 3 years. They have asked me to come back to be a dealer because they cannot find anybody decent in the northeast Wisconsin area and into the upper Michigan to handle the customers. And I know all the way from install all the way, to figure out the BTU load for the house. If it's forced air boiler systems, the only thing we can't do is electric, pretty much, that you can't tap into. But otherwise, everything else you can usually get these to work. But they asked me to come back as a dealer. I'm not sure if I'm going to do that because I don't know if I have the time to actually, be the dealer I should be. With all the land clearing, the wood, the tree cutting, firewood business, and then of course YouTube, it's very demanding. So the stove has got a 8-inch stainless steel stack that is a double insulated stack. So they come with just a short little stack, as you can see. It's just a snub when they get it, and you can add on sections. I decided to go with a 4-footer up there on top of it for the simple fact is I wanted to get it above, get that smoke going above my building. I do not need to have it above my building like most wood stoves. You have to have the draw because it's vented, natural vent or whatever you want to call it, dampered. That needs a draw from air to pull it. So it can't be in between buildings, of course, or below your roof line. Otherwise, you're not going to get the proper draw and your stove ain't going to burn good. This is air induced. So we have actually dual fans in this one. We'll go over those in a minute. But we'll open this up. Right now you can see, I don't know if you can see, but that's 160 is what it's set at, and it's at 160. So we're right now at temp. I can adjust this however I want. This little knob here is a variable speed fan for the bottom fan. Then you have your switch to turn the fans off. And then the light, you can turn the light on the front of it if you want, but I don't use it because I got big LED lights out here for at night when I come to stoke. Biggest thing is make sure you turn the fan back on. A lot of people forget to do that, and then their stove is, of course, not running and keeping up to temp. And they come home to a cold house and a stove that's probably the fire is out for the most part. So the front of the stove, it gets a little black from smoke. That's just normal. I clean that up every year so it looks like new. But we're going to open this up and let it do a little clear out of the smoke because you will get some smoke back in our faces right now because that's just how it is because it's smoldering. But it clears up pretty fast usually, especially the drier the wood, the better. But this hasn't ran for a while. I can tell by looking at the coals. It's warmer, so it's not, I don't know, it's probably 26 degrees, 25 degrees. So it's not going to be flaring up right away. The longer I leave this open, of course, it's going to flare. If I turn the fans up, I turn the stove up right now and kick the fans on, which I could do that here to show you. But then you'll start seeing it really flare up. But you're starting to see here already, it's starting to catch. You know, we're starting to get some fire going already. But if I did turn this up, I just come over here and I can just take that and move the temperature up. So I'm going up to, I think, 166 because I got a 5-degree delta T right now. So we put it there, and now you'll start seeing this really kick. The fans will click on. They just opened the solenoids, the actuators, to put the fan, you know, to get the air in. And now that bottom fan down in the shaker grate down below down there is blowing air up. And then we have in here, there's a tube up top. Up there, that's a secondary burn. That's a fan up there that blows air down to burn the secondary gases. So what that does is basically when your stove is cooking down here and firing up, there's gases that create up top before they go up the chimney. That induces air into that, and it starts that gas on fire again. So it's burning that so you have less smoke going out, and also you're getting a better burn. It's getting rid of the gases and you're gathering more heat that transfers, because there's water all the way around this whole thing. All of those tubes up top, those are all also got water going through them. So we do not have water in our door like some systems do. But you can see there's not much smoke coming out. A little bit. You'll have a little bit going out, but not much. Once this gets really burning, that's pretty much all basswood in there currently. Then it definitely will be just basically vapor coming out. So we're going to close this up. Don't forget to push that in. And I'm going to turn this back down just because, well, we can show you the fans here quick. This is the back of the stove. I took the door off already. The door just slips on and off. Now they have new ones, the new models. This one's 5 years old. The new models actually have a latch. The door opens up on hinges and everything. It's pretty nice. You can see I got here. I have another run I can do. I have it primed or plumbed to run to a house if we were going to build a house over here behind me. We had an area cleared and we had the basement dug actually, but I filled it back in because, of course, we added that on to the house for like a barnuminium style house. So we might add on to that again, but we're not sure. So we have a double run, 4 sets of spigots or bungs they call them, and you have a feed line here, as you can see, and the return line. So I have it ready to plumb and go out. This one is going to the shop currently. So we have the return here with a ball valve, and then we of course have a pump down here. I run Grundfos for the most part. You can use Taco or Bell and Gossett, whatever. But you can see we have isolation flanges on here that are brass. All of these connections are brass. Everything is brass or copper. The reason we use only brass and copper is because of the stainless steel. So being stainless steel, you don't want to mix black or galvanized or anything like that in this stove or you'll corrode. The only exception to the brass and copper is the pump. This is a cast iron pump, but if you can tell here, there is a gasket in between here. So this is brass, this is cast. That keeps them separated so they're not touching, and this will never corrode or give me any problems of corroding up and those two metals mixing together and start causing corrosion, which will get into the outdoor boiler and eventually hurt your boiler, eat it out, and it will also eat this all out, the brass, and eventually clog it or drop some stuff into your pump and your pump will go out. I've seen it, done it, so learned the hard way. That's just a little Grundfos pump because I'm only pumping it about 12 to 15 feet from going down into the ground, down there, out and back up into this corner of the building is my mechanical room, which we'll be going in and seeing the in-floor in a little bit. As you can see, we got a drain down here with a ball valve on it. So if we ever need to drain the stove or do anything with it, it does have that's the blower. That's the big variable speed blower that blows through the bottom, through the grates. And you can see here the solenoid, which is, that opens this little flap and makes the stove burn. And then we have this secondary blower that also with a solenoid that closes. So as soon as the stove is satisfied, this and this will close. So this one here will close. They slam down and they're held down by that solenoid. They do put the plugs in now in the back, so when you wire this up, those plugs are hot. I think they have 4 now instead of 2. But you can put just a cord on your pump, and you can actually just run and plug it in. So that's nice. That wire goes up to the aquastat that's on the side that runs, of course, the stove for your temperatures. So, your delta T for set temperature to kick on temperature. They use all batt insulation. This is all fire retardant batt insulation. It's wrapped heavily around this stove. You can see up top everything. It's very tight. The snow stays on the top of this roof pretty much all the time except the sun when it comes out, because the sun will, of course, melt it because it's black. So that's basically it on the back of the stove. It's a very simple design. The new ones do have these right here do fail sometimes, the actuators, or the solenoids, sorry. They're not that expensive, but I always tell people to have one on hand. Not a bad idea to have this fan on hand, possibly, just in case. This one isn't as important. You can always order it, and for the top so you could always have that sent to you and done later. So it's not a big deal. And then always have a pump on hand. Because of course that pump, if it goes down, it's going to go down on one of the coldest days of the year, and it'll be 9 o'clock at night, of course. And then you have no pump and you have no heat, and you got to worry about freezing. So we're going to go over here, and I'm going to turn this back down. So as you can see here, it's going up in temp. I have it set at 166. We're at 166. So I'm going to turn it down to 160. And you come back here, and these will shut off now. There's a delay, of course. Boom. So they both slam shut. They're nice and tight. So now the wind blowing out here right now won't go into that pipe or in there and make the stove keep going up in temperature, because it'll rise, of course, if you have air leaks. So anyway, that's about it on the back of the stove. The whole water jacket, everything on this stove is stainless steel. There's the only part that's mild steel, of course, is the siding, and all of the other steel on the outside of the whole drum. So the water, anywhere water touches or fire is all 409 stainless with titanium. They do not mix. Some manufacturers do. For instance, Central Boiler is the biggest one in the industry, I think. Well, was the biggest one in the industry, most known. The old Central Boilers were really nice stoves. I thought they were great stoves, actually. They last a long time. There's guys out there that are probably going to leave comments. My stove is 30 years old. Yeah, they are. A lot of the newer ones, though, I've replaced a lot of 5 and 10-year-old Central Boilers, unfortunately. So with Crown Royals. They have a titanium-enhanced stainless steel firebox, but they do not have a water jacket that's stainless steel, which I don't know how you mix the two, but when you have a mild steel and stainless steel, I don't know how you're mixing it and welding it and stuff like that. I did call the company and ask them, and they did say, because on their website it only says titanium-enhanced firebox. It says nothing about the water jacket. So the water jacket is actually mild steel, and she told me that. So I know for a fact that's what it is. Now, they could be changing them. That was about a year ago. They might have changed them. So the water level, just quickly on this, the water level is very easy to see. It's right there. It's just a little valve that basically it slides down in, and it sits in the water. It's like a a bladder, like it just slides up and down, and you want to keep it above the ad. That's important. There is a chemical in here called Control. This actually is built for Crown Royal. It is very important. It's not a gimmick. I have seen stoves after 3 or 4 years of no chemical, being water tested and chemical put in it. I've seen stoves that were corroding so bad the water was disgusting in them. This stove right now, if you took a water sample of this, it's as clean as your tap water out of your faucet. So it is very important to keep up on that. So I think that's it. We're going to head into, oh, I didn't tell you about the ash pan. Sorry. This little door down here is the ash pan. This handle here is the rocker for the shaker grates inside. Don't use it much, but this is where the ash pan is, and you just pull that out and dump it. I just did it. So you just pull that out, dump it, put it back in, and away you go. We're going to head in now into the shop, and we'll show you the in-floor. Okay, so we're in my mechanical room now. So this is the in-floor for the shop. The shop is a 60 by 68 with 16-foot ceilings. It's got 3 huge garage doors. So that, there's definitely some heat loss from them garage doors, but this in-floor does a very, very good job. So you can see here, this is where the tubing comes in from outside. We just put a square bucket in and they pour it around it. The reason I kind of like doing that versus pouring around that tile tubing is that if you ever have a problem with the tubing in the ground outside, you can actually undermine, because the wall is right there, you can undermine, and get that tubing out of that bucket and just slip a new one in. If it's concreted around, it's not fun to try to get new tubing in. You can see there, I don't know if you can see that there is insulation down in there that comes up through the floor, but it's not all the way up in the tile. That's just black corrugated tile. These are 1-inch ID tubing that come in from the boiler, these red pipe. They come up and they go into a plate heat exchanger right here. So that plate heat exchanger is a 30 plate, which is for the in-floor. If you don't know how those work, those basically have 4 spigots on. There's 2 on the top. Come on, there we go. 2 on the top, 2 on the bottom. And so basically how it works is one side, this side is the boiler. So this wood, the water comes in from the boiler. It comes up through this pipe here, and it goes into that plate and comes out this pipe here. So that's basically plate 1, 3, 5, 7, all the odd plates. That's what it flows through because they're separated. All 30 plates are separated. Then the other side is the in-floor, which is plate 2, 4, 6, 8, 10, so on. So because of course the in-floor is a pressurized system, because there's your bladder tank, and the outdoor wood boiler is a open system. That is not a closed system. So before, these pipe used to just come up and go right into that heat exchanger, and that's it. But I decided these pipe here, these white PEX tubing, I just added this year for my domestic. I decided to do it. We didn't use a lot of hot water, but now we do. So I decided to tap that in. So basically it comes up there, goes through the plate. It transfers the heat into this. This is the hot side that comes into this mixing valve on this side. This is the cold side, which basically just comes from the in-floor on the return. So after it goes through the floor, heats all the floor, it comes back cooler. Like it's not running right now, but it's warmer because it's not running. But otherwise it's not, it's usually cooler. And this side is, over here is smoking hot. That pipe is probably somewhere around 150 degrees, something like that. And then on the bottom here is the mixing valve. At the bottom of the mixing valve is the supply to the in-floor. So that's mixed water. The hot gets diluted with the cold. We can set the temp right here on the mixing valve. And then it goes in, goes through. I have a zone valve or an actuator to actually, the thermostat says we need heat. It opens it up and it starts going. It also it comes back over here to the pump. and kicks the pump on. We do have a Taco 007E on this. This is my second pump in 5 years. No, 6 years. I don't know why it failed, but it did. So anyway, I just put another one in because it's got Taco flanges, those green flanges, and they don't switch over with Grundfos too easy because they make different hookups. Now the newer pumps, the little ones, they do actually switch to Grundfos. They're incompatible with each other. Otherwise, you have to put a different flange set on to go to a Grundfos. So the infloor is probably about 120 to 125 degrees going into the floor. You have to temper it or control that. You don't want straight 180 degree boiler water or 160 degree boiler water going in to the infloor because you will blow your concrete apart. So I have there's actually 3 manifolds here. You got the blue are return, red is supply. You can see on this gauge right now, that gauge would be at about 1 o'clock if it was running, but it is not running. You don't hear anything when it runs. You just hear a little bit of the pump, and it's silent. So anyway, that's one of them, and then there's another manifold here, and then you have a smaller one here. It's just by how many loops you have. The in-floor tubing down below, they screwed up. When I put this in, I did all the tubing, and when we put it in, the concrete guys didn't pull it back to the edge when they poured around it. And it's way out in my room, so we had to extend them, splice them, and tie them in that way because they didn't pull them tight to the wall, so they come straight up. So that's an in-floor company that apparently didn't know a lot about in-floor. So anyway, we just did that. We got it done. So all of these are connected. No zones are separated. They're all one temp. So when it calls for heat, the whole shop is set at the same temperature. All it is each loop. When you say a loop, this is this one here and this one here. That's all the same loop. And the max you ever want to be is 300 feet. So you run the supply and you go all the way around. You make sure you come back at 300 feet, within 300 feet. So it gets tapped into those, just QS20 fittings that on the manifold, they're just compression. So they're real easy to hook up. And then you got to build, of course, this mess. It's a lot to it. You got to know what you're doing, but then this is, of course, the water that comes in. This black line is the water, constant water feed pressure from the well that's in this pressurized system. So it always gives it water, or keeps it pressurized and gives it water if it ever needs it. But I've had no leaks, knock on wood, in this system whatsoever, except you have a little bit of buildup here, which is not hurting anything, but that leaked a little bit, and that's just from the water. So we had that dripping down onto this pipe a little bit, but that was right away. You always get a little seepage when you have gaskets, here and there, from expanding, contracting. So we got this tubing. What I did was I extended this. I cut this tubing here that went up into that plate heat exchanger, and I extended it up, and I went up here with the 2 lines. That's a supply and a return from the boiler. So this comes all the way over from the boiler, and it comes around here, and it goes into this plate. This is a 10 plate. So there's 10 plates in here. Of course, same thing, 1, 3, 5, 7, 9, 2, 4, 6, 8, 10. So the wood stove lines, you can see, are the white ones. That comes in super hot and comes out cooler if water is flowing through this to be heated from the water heater. So you can see the red lines here. I come over and I built a tree basically on the water heater. So here's just the water heater. And that is the hot water being dropped back into the water heater because that valve is closed. So the cold water that comes in from up above goes down, gets forced through this ball valve, goes over to the plate heat exchanger, goes down through the plate heat exchanger, comes back out, comes up, goes back over, into the water heater, and basically this acts as a storage tank now. As you draw water, it'll just keep producing more and more hot water off that plate. You just got to throw another log in the fire if you want a lot of hot water. That just isolates it, so if I want to in the summer, I can either leave it run through that plate yet, which isn't going to hurt anything, or you can turn that valve off, and then open this one, and then the water basically is going to flow right back into the water heater, and the electric water heater will take over. So I screwed up here. That's my fault. I actually went below this ball valve because they have two of them on there, which I didn't understand that. But I went below it, and we had hot water in our cold faucets in our house. We had screaming hot water coming out right from the plate because this water is very hot. A lot of times they'll put a mixing valve on it, but I did not put a mixing valve because another leak, they go bad eventually, and honestly, it's you get to learn how to run your faucets. So I didn't do a mixing valve. We don't have small kids or anything, so I'm not worried about it. Where some people put a mixing valve, just like the in-floor over here, but a smaller version. And they do that to mix it so it's not too hot and someone scalds themselves, because that water will be 140, 145 degrees otherwise, where you should have it around 120, 125 coming out of faucets. So basically that's kind of the hookup. I just did this year. So it would have been a little different if I would have did it right away. It wouldn't look, with the tubing going over like this, we'd probably did it a little bit different, but this is what I had to work with because it was existing and not doing it right away. So, but then it's just a thermostat in here and in the house. So you can see here that we took off of this here and we ran that pipe going that way. And this one, a guy came here and had to do some work when I wasn't here, and he built this. I had it ran different, and he built this and put it way out in my room because he thought it would be easier to get in here and change the mixing valve if we ever need to. But it is what it is. So that goes and flows basically over and goes into the house right next door. And there's another setup like this completely, except it doesn't have the bladder tank and everything because we're already pulling off that system. We're pulling off of the pressurized system for that room, and that's what's going through these two copper lines in there. All we have in there is a zone valve and basically the thermostat and a pump. And the pump then just, the thermostat tells the zone valve to open up and kicks on the pump, and the pump starts pumping water when needed. My shop is kept at about 69 degrees. It's pretty warm because my stove is we're only heating around 5,400, 5,500 square feet currently, which if we add on to the house, we'll get closer to that 10,000. So then it, I can turn the shop down a little because 69 is almost too warm to work in when you're in here. But it's really nice when you're laying on the floor for in-floor. It recovers quickly. You open these huge garage doors and boom, it's warm in here right away. You're not trying to heat the air again because that's all forced air does is heat the air. In-floor radiant heats objects. I will bring my truck in here and it'll be all full of snow and slush and stuff. And literally by morning, the truck is completely dry. There's no water left on it, nothing. And the floor is almost dry, if not dry, from the in-floor, basically baking it. So it's really nice. I love in-floor. The only thing is with in-floor in homes, your AC. You have to put an AC unit in. Some people put those Mitsubishi split systems in. That's what we have here, and it works great. So that's about it, I guess, in a nutshell. I didn't want to get this too long, but that's about the outdoor wood stove. Crown Royal does have a 25-year warranty as long as you keep sending in a water sample for the water every year. I may or may not take that dealership on, but I highly recommend the stove. I think they've really grown Their office is up in International Falls, so in Minnesota, which is, you know, the ice box of the country. So it's a good place to test them, and that's where they've been ever since they started. So you can give, it's called Green Tech Manufacturing. You can give them a holler, and if you're looking to purchase a stove, they'll get you hooked up with a dealer in your area. If you're in Northeast Wisconsin and all that, I might be the dealer, and you'll be talking to me, but not sure about that yet. So anyway, that's about it. We got the old rock tamers up there for the trucks for our trailers, but yeah, that's about it. And I appreciate you guys coming along and learning a little bit about an outdoor wood stove install and outdoor wood stoves. And I'm really glad you guys are watching our videos. It's doing really well, and we're enjoying this, and we're really looking forward to meeting a lot of people at shows and different things we're going to be going to this year. So we're excited. So we have a lot of other good videos coming up that we've already got taped, so we're going to be putting them up so soon. So look for that. And I will get to the barbecue wood video here soon. I have not done it yet, but I will get to that video soon. And I appreciate everyone again, and we will see you soon.